Thank you, Melissa. Good morning, everyone. And thanks, Ella, for this really interesting presentation. I truly enjoyed watching you walking us through that. Thank you very much for inviting me to participate in this event. And congratulations to everyone at Vector. As I'm attending this event this morning, I've been thinking a lot about how it was only a very short time ago that Vector was simply an idea on a paper. And look at where we are today with the scale and the reach that this institute has. It's truly remarkable what has been achieved and what this is doing for Canada. It's you're making all of us proud. So I'm here to talk to you today about the work that we do at RBC through our Institute for Research in Machine Learning, which is called Borealis AI. We can change slide. So I'll start with our mandate and the reason for our existence. We're a relatively new group. We are about 4 years old today. We're about 100 people. And we started off on this journey at RBC because we wanted to create jobs here in Canada within a Canadian company that would be meaningful enough for top AI experts, researchers, as well as engineers, to want to stay back in Canada and commercialize their research through a Canadian company. When I was starting off Borealis AI at that time, I was meeting up with my friends from the University of Toronto in computer science who were graduating their PhDs, and I would ask them about what they're planning to do next. And overwhelmingly, I would hear that they would either leave the country, move south of the border, join a big tech company to continue to do research there, or join a foreign company here in Canada. And when I would ask about, have they considered a Canadian alternative? Because it was a lot of this work that was developed here in our own universities. And it felt like a bit of a pity that our Canadian industry wasn't taking advantage enough of what was happening here. The answer I would get was, well, what would I do in Canada? And what Canadian company would I work for? There's nothing interesting happening there. And that was fair. That was right to say. I think the landscape has changed a lot today. And beyond Borealis AI, we see a lot of groups within Canadian companies that have really stepped up and have started to create a world-class ecosystem here at home through Canadian companies. So what we do at Borealis AI, and the reason why we went to RBC to do this, is because RBC is Canada's biggest company. And we felt that we had a responsibility to lead the way and show the way for how research and development can be done in machine learning within a large enterprise in Canada. So our goal is to be a world-class research center and to build products for the bank, which start off with fundamental research in order to achieve outcomes that have a sustainable, foundational, and long-term competitive advantage. So at Borealis AI, we tend to focus on the types of problems for financial services where you usually have to go back to research, solve something foundational there first, and then come back and apply that to solve for a business need. And when we do that, we are lucky enough to be touching the lives of millions and millions of Canadians that bank with RBC and have relationships with our bank. Next slide. Here's how Borealis AI looks today. We have 4 centers in Canada. We're in Toronto and Waterloo. We're in Montreal and in Vancouver. We wanted to be very intentional about creating opportunities for machine learning experts across our country and not just in the Toronto-Waterloo corridor, because we found that there is fantastic research communities, both within the Montreal ecosystem, as well as in BC and elsewhere in Canada as well, where we are collaborating with academic institutions. We are about 120 people today, and we're split between researchers, engineers, as well as product managers and business development experts. So we see ourselves as a small startup within the Royal Bank that essentially has one client, RBC. We publish all the research that we do at Borealis AI. We open source all of our code, and coming on our website, you can find all of that. And we partner with academic institutions, we partner with universities here at home, but also abroad as well, to collaborate on fundamental research topics. And a lot of the time we publish together as well. So we have a number of publications with the Vector Institute in some really key areas that we're focusing. And speaking of that, the next slide has some of the main areas that we are focusing on today. We're very actively doing research in model validation, model stability, bias, and privacy. These are core research areas for us because we are part of a bank, and banks are very heavily regulated. The only way that we are able to conduct machine learning and build AI products in our business, in our sector, is if we can guarantee the safety and sometimes as well the explainability of our models. So we're very interested in advancing the field in these areas, and that's why we have dedicated teams focusing on research just in that space. But we're also very active in NLP. We got a number of groups both in Toronto and Montreal focusing in that space. Time series modeling. In financial services, we have a lot of time series data across our business, and we've developed very strong expertise in forecasting and predictive models for different environments that this can be applied. We're also focusing on semantic parsing. It's an area of research that is very close to our heart, and we're making some really good strides there. Hopefully we'll be sharing some of these results soon. Adversarial modeling, knowledge graphs, primarily in Montreal for Borealis AI. There's a variety of topics, and there's different groups across the Institute that focus on them. In the next slide, I put down a few pictures of the academic advisors that we have with our Institute, the people that are guiding our research, as well as the technical leadership that we have within the Institute. We have been lucky enough to be receiving guidance from some of Canada's top academics in the space. And these include Professor Greg Morey from Vancouver, who's focusing on computer vision, Simon Prince, Marcus Brubaker, Jackie Cheng in NLP, and Leon Segal in vision as well. They have been able to truly help them move the needle for Borealis AI and create an environment where we continue to nurture that curiosity that starts off in academia, in the university, when we're doing our PhDs, and we transfer that and continue to advance that within this group in the industry as well. We've also been blessed with some key leaders that have joined us from the Toronto startup ecosystem, like Catherine Hume and John Nestor, as well as Alex Laplante, who's very famous in modeling risk in financial services. And we've created with these individuals a culture of a very entrepreneurial environment where academic research is at the front line, it's respected, and we have expertise in how we leverage that and build it into products end to end, and then integrate them into RBC products, and we launch them in Canada. Next slide. I'm going to show you some of the work that we do, just 3 quick examples that we've been working on, so that you get an idea of what what machine learning is in banking. And part of the reason why I wanted to do that is because there is, I think, a lot of stigma about what machine learning and data science is outside the tech industry. When we think about this field, we usually think about big technology companies and interesting applications in entertainment, transportation, etc., which are very exciting for machine learning experts, of course. But there are some really interesting problems that are very research-driven and really challenge people from all the way from the data engineers to the researchers to the engineers that work on them, that build them out, that I think are worth mentioning. And I wanted you to take away that this is the case beyond the tech industry, and that these opportunities exist across Canada in many different industries, including financial services. So the first example of how we apply the machine learning that we do is in the next slide, is in the field, so how we apply deep reinforcement learning. We use RL, which is an area where we conduct a lot of fundamental research too, in order to model very complex environments. And those environments in banking, you can find pretty much anywhere in our enterprise, but by far the most complex environment that one can model is live capital markets. So you have this live trading system, and it's a multi-strategy environment because there's a lot of activity happening in a live market. There's different strategies that are working against each other. And so the challenge that we have is, as researchers, is how do we use reinforcement learning in order to make optimal sequential decision-making for the orders that we're trading. This is a very interesting problem, and I think a much more complex environment than the traditional gaming applications that we've primarily seen RL being applied in, and one that has been definitely challenging both our researchers as well as our business partners, because it's a very new type of research, but it's also very interesting to see how you can have live systems that can adapt when market conditions change dynamically. We're also working on detecting interesting signals from the market that can be used to make trading decisions, buy or sell decisions, which is a very tough and competitive space to be in, but one that we're very passionate about. And we're very actively researching in that space as well. The next area of focus for us it's an example from, it's the next slide, natural language processing and how we apply that in financial services. So there's a ton of applications of NLP in banking. One that we are focusing on is in the space of financial analysis. So in banks, you have professionals whose job is to analyze different markets. And you have advisors as well who are supposed to be well informed about what's going on around the world, so that they can provide their clients with the right advice about their portfolios, about their holdings, etc. When I first joined the bank and I met the financial analyst, I asked them, what do you do? What's your job? And they said, oh, my job is to know everything about the consumer electronics market. Or my job is to know everything about the oil and gas market. And when I asked, what does it mean to know everything about something? What's your definition of that? They said, well, my job is to read everything that gets published and have an opinion about that. And not just a handful of companies, we're talking the entire industry assigned to an analyst. So as a scientist, you look at that and you're like, well, this is impossible. There's so much information out there, but as humans, we're limited by the amount of time we have in reading that, processing that. We're limited by fatigue. We're limited by the languages we speak. And so we intended to use machine learning in order to analyze information as it becomes available, as it's published in newspapers, magazines, blogs, online, and make an assessment about how relevant and important that information may be today about a specific analyst. In an essence, trying to model what is happening in a cognitive way today at the particular moment for them, and feeding them with the right information at the right time. This is a very interesting area for us, and it's an area of active research. I could tell you that the moment you're building systems like that feed and receive feedback directly from humans and try to achieve that high-level cognitive process, there are a lot of learnings that come your way. And it's absolutely very interesting how you adapt these algorithms over time as these analysts learn and understand new information. And the last example that I wanted to share with you in the next slide is in the field of cybersecurity. And so we as a bank and every other big enterprise is very, very interested in ensuring that data and our servers are very, very secure. And we're constantly investing in the most up-to-date and state-of-the-art systems for protecting our servers. This traffic on our servers, though, for a machine learning scientist was a very interesting data set that we wanted to explore early at the first few years in Borealis AI. And so we started analyzing SQL data using natural language processing. So the same technology that's used to analyze and model human communication text. Our hypothesis was that we could train the same NLP models to analyze SQL data and make a prediction about whether an activity on our server is malicious or not at a given time. We got a lot of great labeled data. One of the great things of working at a bank is that you can have experts sit down and actually label these data sets for you. In the next slide, I have an example of a SQL injection. Can we flip slides? Of a SQL injection that is a type of attack that can happen where code is inserted in a query on our servers. And what we tried to do here is we fed examples of malicious and non-malicious versions of this code to a deep network, and we used the classification system to determine what a new input is. Using attention here, our system is highlighting which places in the code it actually thinks are abnormal and may depict malicious activity. And we got really high accuracies in this analysis. We wanted to benchmark how well we do. And so we asked our experts in the bank to sit down and do this analysis themselves. And we also benchmarked how much time it takes a human analyst to look at this code. And we humans are extremely good at it, especially experts. They can pick up on this very quickly. We were able to achieve the same speed as a human brain the moment they have an opportunity to process this document. But what's exciting about this is that we are now able to, if we can mimic the same accuracy, get it to the same level and the same speed, we have now the ability to scale that and make that system run live, because we have millions of requests on our servers every hour. So it's It's a very interesting application of machine learning, and one that was not as obvious as we were starting, because we kicked off with a hypothesis of that we could transfer NLP into this domain and make meaningful contributions. In the next slide. So it's just switching gears a little bit and going back to the Institute. So there are a couple of ways that we work with academic institutions, and so a couple of ways that you can reach out to us and collaborate with the researchers and the engineers at Borealis AI. So first off, like I said, we partner with academic institutions. So there's a number of programs where we can work together to collaborate on fundamental research and publish papers together. We have fellowships, a fellowship program that supports machine learning experts that conduct their research in Canadian universities. And the next round of applications is October 30th of 2020. So you may be interested in that if you're doing your master's or your PhDs in this space. And we're also running internship programs all year long. I have a small video. If we have time, we can play it. If not, that's okay. You can always come and find it on the Borealis AI website. But it highlights some of the fellows that we've supported in the last year and that we're really proud of. So I leave it up to the group here if they have time to play it or not.
My name is Anna Golubeva. I'm a PhD student at the University of Waterloo.
My name is Elahe. I am a second-year PhD student at Concordia University.
Bodong Zhang from University of Toronto.
My name is Chenyang Huang. I come from Hefei.
My name is Xianghong Liu. I'm a third-year PhD student at McMaster University.
I'm working with Roger Melko in the Perimeter Institute Quantum Intelligence Lab.
I am working under supervision of Dr. Arash Mohammadi.
Professor Raj Gross, who is my supervisor.
So my research topic is understanding machine learning with neural networks from the perspective of a physicist.
I am focusing on machine learning and deep learning models in rehabilitation and assistive technologies.
My PhD research is about estimating the dynamics of virtual intelligence networking.
A personal companion for the elderly, so that when the elderly lives by themselves, then we can provide some help.
I chose machine learning because it's so new and fascinating.
So they give you a general question, maybe a very new question, or hard to tackle, maybe even does not even have an answer.
Basically out of my mind, so the algorithm is so clever, and yeah, just suddenly get into it.
Machine learning are the most significant innovations in recent years, and as Andrew Ng said, it is the new electricity.
Interests outside of research are mainly sports and arts.
I like to listen to classical music, such as the songs composed by Bach and Mozart.
Basketball and netball, in addition to swimming.
First of all, a very important sign that I'm doing research that is meaningful.
To focus on my research for development advanced AI solutions for improving the quality life of individuals who suffer from neurophysiological disorders.
Kind of such a good honor to get this fellowship. Yeah.
And it proves that hard working pays off.
I know we don't have a lot of time, but there's one thing I really want to say, and I'm going to take just a few seconds to say this. So as you consider your next steps in your careers, as you're completing these degrees, really, I do hope that you can take a step back and consider the shared responsibility that we all have here in Canada to not only be doing fantastic research and science here, but to be also commercializing and bringing these products to life for people through our country. There are a lot of fantastic things happening in Canadian companies today, small, medium, and large, and there are great opportunities for you to pursue within the Canadian corporate ecosystem. So I hope that you will consider this moving forward. Thank you.